Physics is one of the fundamental sciences that helped human beings understand the universe. Physics is a very elegant science. It is both an empirical science as well as a mathematical science. Physics uses a lot of mathematics. Physics was my major in my post-graduation, and I know for sure that mathematically explaining a few things comes before it is explained in a laboratory or explained in a machine. Stephen Hawking never got a Nobel Prize, although his theory of black hole radiation is so very elegant, so logical, so mathematical, and so well accepted. Same thing is about Higgs, the British scientist who wrote in 1964 about the existence of a particle called Higgs bosons, had to wait for 49 years before Nobel Prize was given to him based on the CERN University getting the colliders to measure his theory. We must understand how the sense of space, time and distance have evolved in physics and how it has contributed to humankind. Greek philosophers were famous for explaining various theories, philosophizing them. But except for Archimedes, there was hardly any scientist who has gone into the experimental realm of physics. In 1610, Galileo upgraded his spyglass into a telescope. And that was the major breakthrough that physicists were waiting for. Because human eye can only see that far or this small. So if naked eye were to give the clues to the universe, then we couldn't have been where we are. So Galileo, when he invented the telescope, we were able to see the planets, the stars, billions of miles away. This was the foundation that geocentricity, which was believed earlier to be the fundamental, that Earth is the center of the entire universe and everything revolves around the Earth, was replaced by the Copernicus theory or the heliocentricity, or at least the solar system. It moves around the sun and there are many suns. Galileo also, through his observations, prescribed that nature works as per mathematical simplicity or mathematical beauty. Anthony Robbins discovered the microscope. That was about 55 years, in 1665. Suddenly, something which was not visible to a naked eye became the subject of scientific and physics research. Now, electron microscopes can measure particles with precision, and these are so small. They are, 1/10 of a 1/1,000,000th of a millimeter. A wave meter, which measures the wavelength of a light, can measure small distances 10 to the power minus 18. Photoelectric effect is the theory for which Einstein got the Nobel Prize. It says that electrons get knocked out of their orbits by small light rays. And this happens in called a nanosecond or a attosecond, which are 10 to the power minus 21 second. Measuring absolutely small quantities and measuring small time, measuring large distances, measuring very small electron microscopic distances have contributed to the world of physics. Three more things have contributed to the advancement of physics and the world that we know today: universality, symmetry, and reductionalism. We will briefly deal with all the three. Universality is explained by a simple statement where we say that when Newton correlated fall of an apple to a gravitational force, the same force holds good that why moon is orbiting the earth. Einstein brought his general theory of relativity, where he made a correlation between time and distance. As gravity comes down, there is a lag effect of time. So if we drill a hole from the surface of the earth to the center of the earth, we will find that the center of the earth is about 2.5 years younger than the crust of the earth. It can be told that the time that is recorded in the first floor of the house and the ground floor of a house will differ by 1 second every 10 million years. You may think, what is 10 million years? Who has seen 10 million years? But think of the example of geosatellites. The geopositioning or the directions that you get from the GPS system in your phone, it gets various signals from the satellites that are placed in various orbits around the earth. Now those have atomic clocks, and because of the distance they lose time and they must be corrected frequently, otherwise overnight the distance that is measured will vary by various kilometers and this GPS system will become useless. The second important thing is called symmetry. Physicists interpret symmetry as something which is there everywhere. We know what is a geometrical symmetry. If it is a perfect square, if we cut it into half, both sides can be interchanged. Nobody will understand what is the difference. Similarly, if there is a circle, it is symmetrical from everything. But physicists discover symmetry in every matter. And wherever they see that there is a difference in symmetry, they believe there is an external force. This external force works on conservation of things. The fact that laws of physics work between one time zone to the other has given rise to something called conservation of energy. Similarly, conservation of momentum, conservation of parity, all these things have led to measurement of distance, time and balance in the entire physical system. Reductionalism, or breaking down things into its parts to understand the nature of things and find out if there is any kind of a difference in the laws of physics that is applicable to the components. A new thing is to be discovered, and this has led to the discovery of one of the phenomena which has changed the understanding of nuclear physics, is known as weak nuclear forces. Physics, this elegant science, depends on space and time. Extremely important that we appreciate these basic laws of physics. Thank you very much.